Hello, everybody. This is Arunawa. What's going on? So for this 15 minutes, I'll be introducing myself to you people, and let's see some introductions, and let's see if you all can hear and view what is going on in this session, right? So if you people can see what's in the screen, please like say yes, I'm there. All right. Hello, Gaurav. Hello, Rohit. Hello, Sushant. I'm sorry, Shushnata. Hello, Harry. Now, a lot of you are here from a lot of platforms where I've been introducing. I've been saying that I've been taking this live session, this first date with TensorFlow. So a lot of you have been here from many different platforms. So just if you the thing is that the session that we'll be going through is introduction to TensorFlow. So if some of you are already familiar with TensorFlow, then I'll say that you have to wait for our next session. Something to mention is, okay, someone is saying that the sound is not clear. Is it so? Is the sound not clear? Please say if the sound is not clear. Okay, so I think it's clear. And something to keep in mind is that in Hangouts and Air will be running in like 5-second delay. So what I'll be saying and doing, you will be receiving that after a few seconds, or I think about 10 seconds. So that's something to keep in mind. Okay. So hello, everybody. Gaurav is here. Harsh, Sandhya, Mayank. All right. So how many of you are here from outside India, outside Kolkata? Wow. So Venkata is from, I don't know, uh, didn't really mention. Rohit is from Bihar. Gaurav is from Chennai. Arvind is from Bangalore. Prakash is from Kolkata, but he's working in Bangalore. And Harsh is from UP, right? Okay. Mayank is from Agra. So something to mention is that this session is primarily held for our participants in the machine learning crash course that we have been doing in Kolkata. So this session is primarily for them, and we'll be focusing on things that we have been covering. Things are pretty much we'll be covering pretty much from the basics, and if you guys want anything to be cleared out, you can just say. If it's possible, I'll clear it out in this session, or if not, we can just, I guess I can hold another session sometime. Okay. Um, yes, Srideep, this is for a basic TF. As you can see in the schedule, we have introduction and check, which is right now going on. Then we'll have introduction to TensorFlow. Then we'll have a QA session to help you out. If anything if you missed anything in that introduction part. Then we'll be building simple computational graphs using TensorFlow. And then we'll again have a QA session, which is for clearing the doubts. Then you will build your computational graphs. I'll be giving you what to build, and then you will be giving me the answers. So that I'll check. That will go on for a while. And then we'll be building a linear regression model using low-level APIs of TensorFlow. Pretty much simple, nothing to scare about. I'll be explaining everything as I go. And we'll be having a QA session after every section so that I get that you are clear, that you're getting what I'm saying, and so on. So just so you know that we will be coding in Collab Notebook. So you guys can open up your screen windows, and exactly. Navoni, you should be opening your Collab notebooks and make sure that everything is installed. The things that you need installed are that these ones. I'll just show you. Uh, so I have highlighted on the screen the prerequisites that you need. Harsh, about the Collab window, you can get it by searching Collab Notebook on Google. If you don't know where to get the Collab Notebook, let me just show you. So to get the Collab Notebook, you just have to type Collab Notebook on Google, and there you go. There's the Collab Notebook. And after getting that, just hit New Python 3 Notebook, and you'll be presented with a new Python 3 notebook. Anubhav, for now, you don't need to install these things. So you can just use your Collab notebook, right? And Collab has everything installed in it. So later on, when you are actually working in your local machine, you can install these things. Yeah, Mayank is actually right. Anubhav, you can actually use that command in your Jupyter notebook to install NumPy, Pandas, and Matplotlib. So I'll be doing some basic checks, and till that time, you guys introduce yourselves, and we can move on after that from around 8. Yes, Mishayanta will be working in collabs. And yes, you can also use Jupyter notebooks, Sandhya. The preference is totally up to you, whichever you're comfortable with. I am not using a Jupyter notebook because many of the participants here might not have the libraries installed. So we will be using collabs for now, and then you can actually, yes, Prakash, you will be getting the source code at the end of the session, so you can have the notebook and run it in your local machine or in a collab notebook. I'll be sharing the link. Acha, so by the way, how many of you really ditched your dates to come and date TensorFlow? Anyone really ditched their dates tonight to come and like date TensorFlow? Harsh, yes, you can use Anaconda. Anything you're familiar with, as long as as long as you have access to these libraries, you'll be fine. Exactly, Mayank. TensorFlow is worth ditching dates. Good for you, Rupam. Good for you. Anything that stops you from using TensorFlow, you should kick that out. Okay. So I guess everybody's here. I can start, right? No, no, heavy soccer. If that's really your name anyway. The important topics are not started. We are just going over introductions. Yes, Prakash, the session is recorded and it will be available later too. Anubhav. Yes. Okay. So it's 8. I guess I should start, right? Everybody's here. Yes, we should start, I guess. Yes. Okay, fine. Okay. Yes, Anshul, let's start. Okay. So the first topic that I'll be covering is introduction to TensorFlow, right? So how many of you are already familiar with what TensorFlow is? Okay. Uh, so TensorFlow is a deep learning library and a machine learning library that is used to easily build models without actually going through a lot of the uh, code from building a lot of the code from scratch. Okay, so TensorFlow can be found in tensorflow.org. TensorFlow. This is the official page for TensorFlow. And over here, you can find how to download it and how to actually get started with it over here in the develop section. This is the official documentation for TensorFlow. So coming to what TensorFlow really is at the end of the day is that it's a library with which you actually build computational graphs and then execute that computational graph multiple times using sessions. Okay, so everybody here is familiar with computational graphs, right? Give me a yes or no. Say yes, CG or something like that. Okay, so a lot of you are not familiar with what computational graphs are. I will introduce what computational graphs are in a very low level. So let me just open a Scratchpad. This is not what I'm looking for. Um, sketch. Sorry. Okay, so exactly, Navani, a Wacom would have actually helped me. Anyway, so this is a very basic computational graph. So internal nodes, these are the internal nodes, the ones over here. This one is an internal node, and this one is an internal node, and these ones are the leaf nodes, right? So these the leaf nodes actually contain the values, and the internal nodes contain operations like plus, products, divisions, and stuff like that. So actually that is a computational graph, and which is actually we can compare this computational graph with a basic graph. So what happens is this addition operation is applied on these two, and you get 2 plus 3, which is actually 5, and then this operation, multiplication operation, is applied on 5 and 4, after which you get 5 into 4, 20. Okay, so that's the output of this computational graph. The output of this computational graph is 20. You got it? You got what a computational graph is in a nutshell, people? Tell me a yes or no. Yeah, that happens, Abhishek. Okay, so people knows what computational graphs are. So let's move on. Let's move back. Okay. So yes, TensorFlow is all about building these computational graphs using the TensorFlow APIs and then executing them with sessions. Okay, so what is a session? So for now, I'll not dive into too much detail. For just think about sessions as something you need to execute these computational graphs. You'll get a more intuitive sense of what sessions are when we get into the code. Okay, good. I guess that will be I mean, that's all you actually need to know about TensorFlow in a very high level. But still, since we have time, let's uh, let's actually move on to some of these things. Okay, so how many of you are familiar with Keras? Give me a yes or no. So what Keras is basically it's a deep learning library which actually has these one one function calls for building uh, deep learning architectures. So just think of Keras as building blocks. So when you're building a deep learning library, when you're building machine learning and deep learning models, you have different blocks. In the complete model architecture, you have different blocks, and with Keras, you can actually call one function to build each of these blocks, and then actually you can put these blocks one after the other like Lego blocks to build the complete architecture. That's a very high level overview. And TensorFlow actually gives you that the Keras API so that you can build these computational graphs. So for now, that's something that's all you need to know. Later on, you can get a very good understanding of what Keras is. Okay. Um, Something more that you should know about TensorFlow is that TensorFlow has low-level APIs and high-level APIs. What high-level APIs are? High-level APIs are basically estimators over here. So what are really estimators, right? So estimators are what estimators are is basically they provide the complete model architecture. Okay, heavy soccer. Let's keep the questions for the Q&A session. Okay, for now, let me just go over it, yes or no, and for the questions, we can just keep things for the QA session. Okay. All right. So as I was saying, estimators. Yes. So estimators give you the complete model architecture with just one function call. So say if you're building a machine learning model, you can just call one function and estimators come and that function will return you that complete model architecture. And on that model architecture, then you can just easily call train, evaluate, and predict to train, evaluate, and predict. That's simple. But what does this take away from you? It takes away the flexibility, the model flexibility, the building flexibility that you will get. It takes away that. So you do not get the flexibility of building the models. And that's why we need to dive into the low level APIs to actually build our models from scratch. But not everything is built from scratch, like, right? So we have APIs. So estimators actually does that in a very high level. So you need to get into a bit more depth. Okay. Okay, I think that is all for TensorFlow. Introduction to TensorFlow. So if you guys have any question, just put it in the chat box. I can answer those questions. So, Shreyoshi, what estimators really are is think about estimators as just functions. Okay, so they are just functions, and if you know what a machine learning model is, these estimators just return an object of that machine learning model on which you can call the train, predict, and evaluate methods to actually train, predict, and evaluate that easily. Okay, so actually, if you guys want, I can go over estimators at the end of the session. Do you guys want that? Should I go over estimators at the end of the session? Gaurav, Keras, 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 yes. I'm sorry. I'm attending one question right now. Just a minute. No, Rupam, it's actually very simple. I can just if you guys just give me 20 minutes, I can go over estimators at the end of the session. But so the notebook that comes with the machine learning crash course from Google itself has estimators using it. So if you guys want, I can use that notebook and explain what the code is doing very intuitively. It will not take very long. Okay, so many questions there. Um, Let me take one at a time. Oh, Anusha has a question which says that Keras versus estimators, since both are high-level APIs, what are the differences and which should be used when? Okay, so on a major note, Keras is used mostly because Keras has got a much more higher flexibility. What estimators for estimators, TensorFlow just provides some of the basic architecture models like linear regression, deep neural networks, and like that. But you cannot extend it. You actually can have custom estimators, but that's not used that much. So mainly what's used is Keras API. So when you're actually trying to build machine learning models and quickly evaluate what it's doing, you actually use the Keras API. So am I clear? For Anusha, if you can say I'm clear. Okay, so people wants me to explain estimators at the end of the video, so I will do that. Okay, so bear with me. Uh, I will do explain estimators. Any more questions? Any more questions? Let me see. Lower level APIs have to be defined again and again for use. No, it's not. It's not like that. Shubhajit, lower level APIs does not need to be defined again and again. You just have to build a computational graph once, and then actually you can execute that same computational graph again and again using sessions. So, am I clear, Shubhajit? Okay, Gaurav has one question. Curious versus difference. No, Gaurav. There is. I don't think there is much difference. So I've been using the TensorFlow Keras API myself, and I have went through the docs of Keras actually, and I don't think there is much of a difference. I may be a bit wrong. So is it clear, Gaurav? What's like creating a model, Rupam? Yes. So the estimators are actually creating a model. At the end of the day, what you're doing is you're creating a model, right? So for estimators, you are just calling one function saying that I need this model, and that um, can you please repeat what you just said? My internet was not working till now. Amartya, actually, I can't actually recall what I just said. I guess you can just start a bit, uh, push that red bar a little bit to the back, right? Okay. So what I was saying, was, yes. So yes, and the work of estimators is actually creating a model. All you're doing is you are calling just one function, and that function is actually fetching a basic structure, a basic computational graph that is built by the TensorFlow team at the back. But you need more flexibility than that. So you have to code a bit of it from the scratch. Okay, any more questions? How much time for beginner? How much time we can spend for learning TensorFlow? Ankush, I think you should put yourself, give more time learning TensorFlow, because TensorFlow is actually one of the best deep learning APIs that is currently there. So, yes, give yourself time. Put yourself time. Go through a lot of notebooks and see how you can get your head around how TensorFlow API works. Okay, so I guess we are done with the questions, and I can move on to the next part, which is live coding. So if you guys have your notebooks on, give me a yes. If you have if you have your notebooks on and things installed in your machine, give me a yes. I'm waiting. Anubhav, you can open a notebook in Collab. Yes, so you can go. You can do that. Okay. Uh, okay. Can you guys say that if the code is visible on the screen, like it's not too small for you guys to see, right? Yes, Ian is saying that you can increase the font size. Okay. 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 Uh, is it clear now? Is the font size clear? Everyone say yes or no, please. And before moving on, Shandikta is saying that if I can read and okay, I'll increase the font size a bit. I guess it is okay. Let me check myself. I guess it is okay now, right? You people can see, right? Yes, they can see. Okay. Um. All right. All right. Okay. Coming to the question that someone has. Oh, you removed it. Fine. Okay. So let's start with tensors. Oh, okay. Debjit is saying that the font size is not visible. Is it so? Is it so? I'll increase it a bit more, but then I'll have problems. It's too huge, man. Anyway, chalo, fine. So, okay, yes, please clear the font size issue, then I can move on. Oh, okay, let me introduce you to the moderators we have here, which is Six and Adrish Day. Six and Adrish, can you please introduce yourselves in the comment section? Six and Adrish. Okay, there's a, all right. So six is here. I guess Adrish is not here, right? But it's fine. Okay. Adrish is no. All right, fine. Okay, so we'll be starting with what tensors are. So to think about, to first start with, think about tensors as just multidimensional arrays. So let's define some tensors. Okay, yes, Adrish is here. All right, so let's define some tensors. So if any one of you are running into any sort of problems, then please say so in the comment sections. I can clear you out. So that's a tensor. A tensor that contains the constant value 2. Let's print it out. Let's print out the tensor. Let's see what it prints. Okay, so something you should note here that it actually didn't printed the value of 2. It printed a tensor object which says that this is actually the name of the tensor, const 0, and this is actually assigned by TensorFlow unless and until you mention what the name is going to be using the name keyword, which I'll be showing. Let me just show you that. If you just use the name keyword and say my first tensor and then empty one out, and you see that this is actually my first tensor, right? Okay, so this you can actually change using the name keyword, and the shape is actually the shape of the tensor, which is actually, since it's just one number, it isn't there, and this d type actually says what is the type of that tensor. Okay, so are we clear with what tensor is? Tensor is a multidimensional array, and what tf.constant does is actually it allows the tensor to have a constant value. That's all. Okay, let me define some more tensors. This time let's have a 1D array. Something you should be noticing, something you should notice is that while printing out the tensors, we are actually not getting the values that the tensor has. We are actually getting a tensor object. So That's something to keep in mind. And that is why exactly you need sessions. That is because with TensorFlow, when you define tensors and operations, you're actually just building up the computational graph. To execute and actually see the value of that computational graph, you need to execute the same computational graph with sessions. So let's just execute the value of these tensor using sessions. You see, now the value 2, which has been stored in the tensor 1, in the T1 tensor, is printed. So now you'll get the tensor value 2, the value of the tensor T1, which is 2. Let's just print the next tensor which we had, right? The T2 tensor, and see what its value is. Now you'll get the array. Okay? Yes. So this array has 1 and 2, and there you go, 1 and 2 with the type, D type, float 32. Okay, so are we clear up till now? Whatever happened, like we built the tensors, we executed, we saw what the value of the tensor is using a session. Is it clear? Gaurav says yes. So what about the rest of you? Is it clear what happened? Like we built tensors, we ran tensors, we actually we created tensors, and then we ran those tensors and saw what the value of those tensors are using sessions. Arvind says, "How are you executing the code? Any shortcuts I'm using?" I'm not using any type of shortcuts. I'm just typing, right? So in case Anubhav says, why is the column number not being shown or any number not being shown is in the shape of TF, is that is it's because in this case, in this one over here, since it's a constant value, it doesn't have any array. It's just a constant, just a one number. It doesn't shows any value over here. And over here it's just has one dimension, so it just shows the one dimension and it's blank for the next one. Actually you can reshape these tensors to get a one over here, which shows it has got two rows and one column, right? But it actually uh, doesn't matter that much. You can actually get that from here. Jaydeep says, "What is a session again?" So, Jaydeep, for now, just think of a session as a TF dot session is actually returning you a session object with which on which when you call the run function, you can actually get the value of the tensor. That's all. As simple as that. TF dot session returns you a session object, and on that session object, when you call the run function and pass in a tensor object, you actually that returns you the value of that tensor object. It can't be explained simpler than this, right? You got it right, Jaideep? Devjit says, shape. What's your question, Devjit? Devjit says, I'm sorry, Devjit, I can't find your question. You just have written about shape. What about shape? Okay, so are we clear now? Can we move on to like a little bit higher dimensional array with TensorFlow with the tensor objects. We can move, right, people? Give me yes or no, everyone. I guess so. Okay. Okay, so let's move. Okay, so let's define a more involved tensor, which is which has more dimensions than one. It's simple for you people, uh, just to give you a basic sense. Um, okay. And if you print 3, then actually you get the tensor object with the shape 2, 3. Because why the shape 2 of 3? Because it has 2 rows and 3 columns. 1, 2, and 3. 2 rows, 3 columns. That's how you get the shape of 2, 3. And actually, using the session, we are printing out what the value of that tensor is. By the way, so when you are done with sessions, when you have executed your tensors and you are completely done, so and then you have to call ses.close to close your session. Okay, so now you have closed your session. All right, so you should do that after using your sessions. Ses.close. Now, uh, to actually use sessions, there is a one more way with which you don't have to manually close it, which is with ses, sorry, with tf dot session as ses. Okay, so with this one, you can actually run your sessions and you don't have to manually close it. So there you go. Okay, any problem up till now? Any problem with running sessions? You're getting any code errors and anything? Shanta says, can you wait for a few sec after typing a code line? Okay, Shanta, I guess I can scroll up a bit and you can follow up. Okay, everybody, your code is running, right? So we can move, right? Yes, Jaideep says carry on. All right. I guess we should move. People, yes or no, please. Spam कर दो पूरा chat box को. spam the complete chat box with a yes, with yes or no's. Anubhav is having some problems. Adrish and Six can handle you. What's the problem you're having, Anubhav? Okay, so we'll be moving. Okay, so we'll be moving, and the next thing that will be coming across is building some computational graph. All right. So this one was a basic computational graph, and I will just clear this one. And actually, let's. Do I have an eraser here? Yes, I do have one eraser. Okay, so I'll be drawing the exact computational graph that I'm going to build, and then I'll be giving you some computational graph which you will build by looking at these. Okay, so for now, I'll be helping you. Okay, okay, okay. So Anubhav got it working. Thanks to all of these guys who helped Anubhav. All right. I guess I drew the same computational graph the previous time. But anyway. Okay, so let's actually build this computational graph. Let me see if I can share two screens at once. Uh, Give me a minute, people. Give me a minute. Got so many screens. Okay, so I guess my face was visible for a moment. So just ignore that. Anyway, I didn't expect that to happen. So we're building this computational graph, and let's move. Okay, So first, the thing is that we have to add these two numbers and then multiply it with 5. Looks simple, but the thing is that you have to actually, yes, is the expression for yes. Okay, let's see. Comp, I'm just gonna say cg1 f dot answer. Um, so then when you define the nodes, then the computational graph is nothing but this. Alternatively, see, the node 1 and node 2 are tensors, right? Node 1 and node 2 are tensors. So when you're building your computational graph in TensorFlow, you need your nodes to be a tensor object. That's the most important thing. And yes, and alternatively, what you can do is, okay, so these two lines are actually doing the same thing. Okay, Harry, CG1 is defined over here. Is it okay, Harry? CG1 is defined over in the line highlighted. That's where I'm getting CG1 from. So is it clear what I did in this node cell? I mean, in this cell has no attribute tensor. Cool. Mm, that is weird. Oh, sorry. My bad. My bad. I'm sorry for that one. Define a constant. Node 2 is not defined. What? Sorry. Node 2. So these are the errors that you will get when you're live coding. So anyway, everybody, is it okay? Is it running? Now only Shomon, you're getting some errors. Yes, Debjit, I'm holding. Uh, check it out if you're able to run this code. Well done, Avni. Everybody else, is the code block executed? So we can move on, and then what you can do, actually you can execute this using session. So let's execute it. Execute it session. Df session as ses print ses dot run cg1 cg11. You'll be getting the same value because you are actually building the same computational graph. Okay, so actually these operators are actually are overloaded using operator overloading. So what TF multiply and what this multiply is doing is actually the same thing. Okay, so if you're not sure what operator overloading is, just ignore that. Just think this, that these two are actually doing the same thing. This multiply operator and this TF dot multiply function is actually doing the same thing. Okay. Okay, now let's execute this. And there you go, 25 and 25. The same computational graph built in two different ways, executed twice. Is it okay? Everybody, spam the chat box. All right, people. Okay, so let's move on to building the next computational graph. It will be a little bit more involved. Okay, so let's do that. And I should have a select option here, right? Uh, delete, delete, delete. Yeah, just use my eraser for now. Fine. Okay, okay. Let's build a more involved computational graph. See, at the end of the day, what it comes down is to building these computational graphs. And over here, what we have is I'm using a scalar quantity for these leaf nodes. So what you will need to use, this is a 10. Okay, what you will have in your node values is actually tensors. I mean matrices, huge multidimensional arrays, huge arrays. Okay, that's all about all of machine learning and deep learning is like is actually about manipulating huge matrices. I'm talking about deep learning. Okay, it's all about manipulating like huge matrices and vectors. Okay, so uh, actually I'm extremely sorry for my handwriting over here. Hope you people can catch up, and if you have any problems, please comment. I'll figure it out. Help you figure it out. Okay, let's build this one involved computational graph, and then we will move on to building computational graphs using. Okay, so is the computational graph looking good? Shanta has one question which says, "What are vectors in deep learning?" Vectors, just think of it as one-dimensional arrays. Okay, let's build this then. I actually have to look at the computational graph myself. 7, 8. Okay. These are the seven leaf nodes that we have, and now let's build the computational graph. CG2 is equals to PF, PF node 1 plus node 2. Okay. Um, minus node 2 plus node. Sorry. Okay, so we have built the computational graph. Yes, Shanta, we are actually finding the max of these two little subparts we have over here. So we are actually finding the max of this subpart, which has the maximum value, and this subpart. We are actually calculating the max. Yes. Uh, okay. So you people have run this code block. Any problems with running this code block? Harry Hart got the answer. 3.5897. So let's execute this with session and see. That's exactly right. 3.5897436. So if it's anything else, I think you have some issues. You've made some problem in your code. So are we good? 3.5897436. Okay, this is the computational graph. Who asked for it? Shoshi. Okay. So if everybody is okay with this and everybody got the answer 3.589, all we are doing is actually building a little bit more involved computational graph and executing that graph using sessions. Oh, Anu thought it's 14.5. It's I'm sorry, Anu. It's my bad handwriting over here. Please ignore that. Anyway, so everybody's cool with this one, right? Nothing too much complicated. We just built a little bit of computational graph, and then we executed the same with sessions. Devjit, here is the code. It's right on the screen. You can see it. Okay, I'll be moving on to the next computational graph. I'll be keeping this one open in case you guys need it. Okay, are you people like you understood what computational graphs are and how you execute it? Do you people should I move to linear regression and like if you want to have some ask some questions, then I can do that. Actually, I was planning to build one more computational graph that has actually vectors inside it and execute it actually with vectors and scalars multiplied together. Yes, yes. So should I move to the QA session and or show some more? Okay, so we are going to. All right, all right, all right. So one with the vectors. Okay, this time instead of max, we are going to calculate with min. So I'll be keeping very small vectors over here. This is 9, 10, and 11. I'm extremely sorry for my handwriting actually. I should get a walk-on. Navonil was right. 'Cause this is actually taking me a long time. 6.5. These are actually dots. Adrish, can you check out Shanta's code? I think she's getting something wrong. Shanta, I think uh, Shanta, I think you messed up what node one, node two, node three is. I think you exchanged one of these values, and that's why you're getting an answer which is different. I think you are fine. Your code looks fine. Oh yes, Harry is right. A node five, node into node six. Right, right. Okay. Okay, man. I should have actually worked these computational graphs out before starting the session. 6 point. That's all. That's all. From the next one, actually, I'll be using PNGs. This is actually taking a lot of time. This is the last vector. Bear with me. Okay, so this is the computational graph. Now, people, I need you to build this computational graph and see what your answer is coming. Okay, so go to your notebook, and I'm actually typing this out, and yes, I'm actually typing this out, and don't see my code, do it yourself, and then let's check if it matches. Okay, hands on, let's go. Seven point six five, 9.0, 6.75. 7.65, 9.0, and 6.75. 6.75. Next one, which is 14.5, 7.18, and 17. So we've got five nodes: 1, 2, 3, 4, 5. We've got 5 nodes, keeping it as simple as possible. Then we need to multiply node 1 and node 2. So node 1 into node 2. Okay. And then we need to divide the result with 5.6. So that will be node 3, keeping it in first bracket. And then we need to find the minimum, which is found using tf dot minimum of this and this subpart, which is node 5, sorry, node 4, and plus node 5. Let's now execute this session. Ses.run cg stream. Okay. So everybody's getting 11.25, 14.28. Did I mess something up? Did I make a mistake somewhere, people? Can you please tell me if you have gone through it? Oh, this one is 9. Oh, see, it's my handwriting and I actually cannot figure it out what it is. My God. Yes, now I got it. Okay. Right. Thanks, thank you, Gaurav, Sarthak, Shaunak, Venkata, Sarthak. Okay. So, was it fun? Like, we built 3 computational graphs, and I guess you can build some more on your own, right? So if you want, I can share you a PNG, and I guess you can build your own computational graph, right? Okay, so I'm sharing you a link. Okay, so I'm sharing you one link, and I need you to build that computational graph. Okay, enough with drawing in Sketchpad because this is getting really messy inside this one. So let me check out the link and I'll be sharing you with that. Okay, let's see. Harry is getting an attribute error. Where are you getting it, Harry? Gaurav is saying for a second date. Yeah. TensorFlow is forever, Gaurav. You'll have to marry it. Okay. Uh, okay, give me some time. I need to. So I'll be sharing a link for the PNG of the next computational graph, and I need you to build that computational graph on your own. Okay. So, and I'll be coding the computational graph in the notebook. And till then, I'm starting the QA session for complete. Just a minute. Just a minute. Yes, for the simple computational graph building and this one. Getting confused myself. Yes, this one. So we have built simple computational graphs and executed them. And now I'm starting the QA session for this computational graph building and executing them. You can ask your questions, and then I'm giving you, I'll be giving you two PNGs. If you want, I can give you just one. Okay. And you'll be building your own computational graph. For now, we are here. QA session. Anything, any questions you have until now? Push them. Argadeep has one question which says as why are we using different nodes for the same value? So Argadeep's question actually comes from here where we have node 6 and actually node 4, which is actually having the same value 10, but you're using different computational graph, different tensors. Can anyone answer this question? Like, why are we using two different values? Okay, so I'll not wait for you people because you have a lot of questions. So the thing is that actually you can use the same tensor, but then what will happen? What will happen is this graph won't look like this anymore. Will this graph look like this anymore? No, it won't. Right? This part over here will not exist anymore, and this will actually point to this. Yes, exactly, Shoji. Just for simplicity, you can actually have those point to the same tensor, but in case you're updating your tensors, then it will be a problem because it's pointing the same tensor. Am I clear? uh Arkadeep and Shreyoshi, am I clear? Harry, I'll be sharing the PNG just a second. I need to upload it, right? um Check. Give me some time, I'll be sharing the PNG. If you people have any other questions, please ask. Adrish and Six will answer you people, and I also. Okay, Shreyoshi says that if we can upload the PNG as homework for later on, are you people willing to do it live? Like you will solve it and we can debug. I can I6 and Adrish can debug it on a live session, or do you want it at a home as a homework? So spam the chat box by saying homework or live. Come on, go. And I'll be going with the maximum count. So I'll be using a tf.max. Okay, so major amount of the people wants it as a homework. So I'll be actually going. So okay, I'll be actually giving it as an assignment. So yes, okay. So it's an assignment. Sanidhya, I think you can just join the MLCC Kolkata Slack channel if you're not already in it. I'll be sharing the link at the end of the at the end of the session, and if you have any questions, we can go through it. Anybody can help you out in that workspace. Okay, so I guess we are done with the questions, and so we'll be moving on to the TensorFlow. Building linear regression model with low-level TF APIs. Right? Everybody up for it? Okay. Should we move? Yes or no? Okay, so a lot of so for the people who wants this to be live, I think I can take it up at the end of the session, or if you people want, I can take it as give it as an assignment. And yes, Gaurav, there is one MLCC Kolkata Slack channel. I'll be sharing the link after the at the end of the session. You can join. Okay, all right. So we'll be moving to linear regression using low-level TF APIs. So So you're building a linear regression model, right? Okay, one of the moderators is saying that there are some questions left. I guess it is okay to take it at the end of the session, right? Uh, I guess I'll take it at the end of the session. I'm starting with linear regression. Okay. Is it okay? Six and Adrish, is it okay? Should I move? Okay. So you're building a linear regression model using low-level TF APIs. So when you're building a model, the first thing that comes to one's mind is that you need a data set, right? You need a data set on which you'll actually use that model. So for now, I'll be not pointing you to some any of the data set that is already over in the internet. I'll be actually creating a dummy data set live over here, and we'll use that data set to evaluate our model. Okay. So linear regression is what linear regression model is. If you don't know, is actually it builds it. What it does is it draws a straight line. Just a minute. If I can clear this up somehow, blank create. Okay, answer. So if this is your 2D plot and if these are the data points inside it, then what linear regression does is it actually draws a straight line. This is not straight, so please ignore it, but just think of it as straight. So it draws a straight line and tries to minimize the errors that are present over here. So this line over here will actually move and see which one is the best, which one for which position of the line, the error between these points gets minimized, and that will be chosen as the model. Okay. So we'll be actually, this is the model, which is actually the equation for the for a straight line is mx plus c. But in case of machine learning, what we have is wx plus B, where W is the weight and B is the bias. I'm not going to write this one because I'm not on Wacom. So this is bias. Okay. So let's build this dummy data set and let's do this. So you people understood what I said, right? And then I'll be adding some noise so that it gets random. What is star x dot shape? So everybody who is in MLCC Kolkata in the offline session, uh, if I can recognize you the next day we are having a session, I'll be giving you some stickers. So who can answer this? What is star x dot shape? Anybody? Six and Adrish, can you type in the question? Devjit said first. So shape of the NP array. Yes, it's the shape. But why are we using the stars, Devjit? What is 1300, Jaydeep? You know what? You know what? Uh, so Devjit is right. Devjit and Shan. I'm sorry, I cannot. Uh, Shan Dipto is right. So it is the shape of the array. But why are we using the star? I'll just show you. See, I'm getting an error. Yes. Okay, okay. I'll be giving the answer. So we are using a star because when you are saying x dot shape, it is actually returning a tuple. But what Rand needs is not a tuple. So we are actually using star to specify the Shrideep. There is no concept of pointers in case of Python. Exactly. So Nobunil is right. The star is for converting them into arguments. Right. Okay. I'll be moving on. Okay. So now we have created our data set. Right. Fair enough. So yeah, Nobunil got it right, but Nobunil will not be coming to the MLCC session. Devjit answered it first, I guess. So I'll be giving Devjit some stickers. Devjit will be getting some stickers. So yeah. Okay. Okay. So our data set is created. The x's and y's are created. Okay. our x's and y's are created, right? Okay, so the next thing we need to do is we need to divide this data set into training and test set. Uh, Next thing we need to do is to divide this into training and test set. So let's divide it. So for the first 250 points, we are actually including those 250 points in the train set, and the last 50 points, we are including it in the test set. Okay. Is this code block clear? Shantan, we will not need a validation set for now because we are just roughly building the model. Yes, you do need a validation set in production cases, but in case of for now, you don't need a validation set. Okay, so let's move. My question is, what are hyperparameters? What is the difference between hyperparameters and parameters? Keep answering the question. Okay, so let's now visualization the data set for the first 10 data points, and then we'll move to creating the model. Okay, so are we clear up till this? So we have created the data set, and we are now visualizing the data set. Okay, please give me a yes or no that everything up till this point is clear. Okay, I'll be giving you 2 minutes to catch up, and I'll be using those minutes to actually bring more variation in the data set, because it actually looks like a completely straight line. Just a minute. Okay, so we are good. So we have this data set, and I'm just plotting the first 10 data points. What I was trying is to bring in a bit more noise in the data set. Okay, so there is a lot of noise right now, and if you don't want to visualize the first 10 data points, and you just want to visualize the next say 20 to 50 data points, then we can do this. Okay, so that. And why am I not visualizing this data set completely at once? Because this is actually a straight line, and if you not a straight line, but there is noise, but if you there is actually 300 points. So if you visualize it completely in this small space, it will look like a straight line. That is why I'm just plotting a few of the points so that you can actually see the variations. Okay, just keep it from 50 to 60. Something random. Okay, so let's move on to the building the model. Okay. So what is the first thing that we need when you're talking about building a model? We need input parameters, right? So there is one model. There is a model, and if I just hit a new blank create, so there is one model. Yes, this is the model, and this model needs some inputs, right? And for every iteration, this inputs change, right? This inputs change for every iteration. Okay, so we need something that can hold different values on different iterations. And that's where tf dot placeholders come in. Okay, so I'll be quickly defining what placeholders are. Let's define, let's use placeholders. Let's use placeholders. Okay, so we will be having x, which is tf dot placeholder, tf dot float 32, name equals x, y is equals to tf dot placeholder, tf dot name equals y. Okay, so these are the placeholders which will actually contain the input parameters, the for one iteration. Okay, so what are placeholders really? The placeholders for contain the input values, the x's and y's for each iteration. Is it clear? Okay, so then let's move on to build the linear regression model itself. So what is happening in the linear regression model? In case of the linear regression model, all you are doing is you are actually building up, creating a straight line. And what is the equation for the straight line? Mx plus c. And what's the equation for the straight line in case of machine learning? It's wb plus c, where w is the weights, sorry, wx plus b, where w is the weights and b is the bias. Okay? So let's define w. Now, the question is, why do you need a variable? So placeholders are there for taking a different input and output values for each iteration. And then why do you need variables? Because you need variables because because it changes, the values of the variable will change at each. Exactly, exactly. Gaurav is right. So weights change at every iteration, right? So since you're changing the value of these, the values that will be stored inside these, inside W is not, yes, sure, she's also right. So, okay. So the values that are stored in this W will change at every iteration, and that's why the values that will be stored are not constant, and that's why you need variables. Okay, that was simple. Uh, Wait, one f dot variable 0.0 name is 1. Okay, and then what is spread y? That is the model. The model is w into x plus b. That is the model, right? Everybody clear? Okay, so let's move on to the next thing which we have inside a model, which is actually building a, which is actually having a loss function. Okay, so we have this inputs, we have the model, then this model will be predicting some noise cause of some values over here, and this is actually the predicted values, spread y, and this and the true values. These are the true values, and for these true values, we need this predicted values, and these are true values, and we need to compare them using a loss function. Loss function. Okay. So let's get the loss function working. Loss. Okay. So is the concept of loss function clear? We'll be using a very simple square error loss, because some of you might not be familiar with the other loss functions. So it's just a very, no, it's a square error loss, people. What does reduce mean do? Okay, so are we clear up to here? So we have the loss function going. Uh, yes. So we have the loss function going. So yes, people, are we clear? Can you please give me a yes or no? Yes, I know what you meant. Okay, so what's the next thing that we need? The next thing that we need is an optimizer. Okay, so we need an optimizer to update the values of these variables by calculating the by using this loss function and calculating the derivative with respect to these to the values that are present in these variables. Okay, Shanta says it's somewhat clear. Shanta, we will have a live we will have a QA session at the end, so you can put all your questions at the end. Okay. Let me just quickly iterate over the building the model, get an understanding of what's going on, and we'll have a QA session at the end. All right. Yes. So we'll be using an optimizer to update the uh, weights and the biases. Okay. And one of the coolest things when it comes to deep learning libraries is that they use auto differentiation to calculate the derivatives. So you don't need to actually calculate the derivatives with respect to the loss for every variable. Okay. So we build the optimizer using the learning rate, and then we are saying that we want to minimize this loss. Okay. All right. This is not needed. That's not executed. So we have our optimizer ready. So we have our optimizer ready. Now, let's move on to actually building this session. So we are actually done with building the computational graph. Now we'll be executing this computational graph using sessions. Okay. So before moving on to the TF session, should I hold a QS? Should I wait and should anybody needs to clear any questions? Should I wait? Okay, so everybody says to move on. Let's move on. So we'll be executing this computational graph using sessions. Ravi, the error in dot minimize loss was that I was not using this because I cannot just it was one line of code. I broke it into two lines, so I need to use a backslash. I mean a forward slash, I guess. I don't know. So you need to use this one. It's a syntax error. Okay. If you guys Shreyashi and Ravi, if you write it in one line, then you don't need to use it. Since I broke the code into two lines to for viewing purposes, so that's why we need to use it. Okay, okay, let's move. Okay, now is the first time we are having a graph which is having sessions inside it. Yes, right. So I mean, sorry. This is for the first time we are having a graph which is having variables inside it. Okay, So since we're having variables, we need to initialize the values of these variables. And every time, there's a value, there's a variable inside your graph, you actually need to run this code, which actually initializes the values, the variables inside your graph. Okay, so this line of code actually initializes the variables. Okay, so you need that. Uh, okay, next we'll be executing the graph for n epochs. What is n epochs? N epochs is defined over here, which is 1,000. So what does epoch mean? Epoch is like if you have your complete data set, one complete iteration through that data set is one epoch. So we'll be moving 1,000 times over the complete data set, which is 300 data points, which we have over here. Okay. So for epoch in range of n epochs, I'm using a range because epochs is a number and range will return a list. Okay. Now let's execute the graph for one epoch and in this line, what we are doing is we are checking if the interval, which is actually set to 20, is getting divided, is a even, is gives a reminder of 0 for the current epoch. And then only we are printing it. Why are we doing this? Because we don't want to print for every epoch. That it will get messy. The output will get messy for it will like print for 1,000 times. So I'm using interval of 20. Sorry, I'm using an interval of 50. Let's make it to 20, or let's keep it 50 since it's 1,000. It will be executing a lot. So for every 50 iterations, we'll be printing out the loss. That's what this line of code does. Okay, let's do it. Int loss after epoch is loss. Okay. So for one epoch, I have run this. I run the optimizer. The optimizer will update the variables and we'll get our loss functions. If if the epoch matches a certain interval, then I'm printing that loss out just to check if my loss is actually decreasing. Okay. Then actually after this, after all these epochs, our model will be trained, and then actually we can use this trained model to predict on our test set, to predict and see how really our model is doing on the test set. Okay, so let's use the test set. Okay, so we are getting actually overshooting this. Okay, how many of you can say what is why are you getting a nan over here? Open question. How many of you can say that why are you getting a nan? Okay, so Devjit says it's not a number. Simran says it's not a number. Um, says diff is not a number. What is diff? Devjit, what is diff? What is diff, Devjit? Difference. Difference of what? So the thing is, the reason we are getting a nan is because we are actually using a learning rate which is actually so high. But Shandita says that n epochs is 1,000, but our model has only 300. What? Okay, so I'm focusing too much on the chats. Anyway, let me just concentrate on the code. So the thing is that why are we using? Why are we getting an and, right? So we are using a learning rate which is actually falling into a very not a local optima, but at a place in the graph where we are actually not, where the cost function for the weights and biases is actually increasing rather than decreasing. So if I do this same thing for all of the iterations, right? And if I just put this code out from here, and if I actually print for all of the iterations, and let's see what happens. What? Right. Sorry. Oops, 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 oops. What is happening? Hmm. Oh, and let me just write this line of code over here and comment these two lines out. Let's see. So now the loss for all of these epochs are printed out, and let's see what is really happening. Let's see, the loss for the first epoch is this. Loss for the next epoch increases. The thing is that our loss should decrease, but it's actually increasing. So the weights, the variables weights and biases are updated in such a way that our loss actually increases. So then it increases more, and then it actually goes out of the range for Python. That's why it shows infinity. And then we are actually, after some iterations, what we are doing is actually we're calculating operations. We are doing operations on INF. That's why we are getting a NaN. So what is the solution to this problem is actually decreasing the learning rate over here. So we use a learning rate of 0.001. So I'll be decreasing the learning rate more. And actually what you can do is you can try and see what works best and what gives the lowest error. Okay, and then let's execute this again. Still we are getting an AND. But, okay, oh, you need to run this line of code again. Because you get an AND because you need to run this line of code, because over here, the gradient descent optimizer, the object is created using the previous learning rate. So you need to rerun this line so the optimizer gets reinitialized and then rerun this line. Okay, so see, now the loss decreases at every iteration. Okay, 1, and then it slowly decreases. So let me just not print everything, comment this out, and let's just print for every 50 iterations. And there we go. So the final loss is 1.0560812. Are we clear? Give me a yes or no, people. So we just executed our computational graph, our linear regression model, and we optimized the variables using the gradient descent optimizer, and we have achieved a loss of 1.0560812. Yes, Anubhav can't execute. Anubhav, you will have problems. So just say what problems you're having, because we can clear it up. Yes. More learning rate is choosing of the learning rate is one of the most important things when it comes to machine learning. Okay, let's see. Gaurav says, what is the learning rate you have used? This is my learning rate. Okay, so people bring in your questions. And Shanta says says that she couldn't get something clear. What is the problem that you're stuck with, Shanta? Shrishi, your final loss is stuck at 25. So what you need to do is you need to actually, I think there's something wrong with your learning rate. Since it's running, I think it's something wrong with your learning rate. So if you tweak your learning rate and see if it runs. Anubhav says, can you explain how the optimizer is working? Okay, so I'll take that question. So I'll be giving you a very, very high level overview of how optimizer works, Anubhav. Okay, since a lot of you are here, and I actually we have been it's 2011, 2211. Okay, so how an optimizer works at a very high level. Okay, so you have your model. Okay, and in your model you have a lot of variables, which are actually a lot of variables. This is the weights and biases, which are actually used to predict a value. But these weights and biases are first initialized at random, right? So whatever the prediction will be in the first few iterations are basically just noise, right? Are basically just noise. But we have some true predictions which we need to achieve. So we compared this noise with the true predictions to get using a loss function, to get using a loss function to get a loss. Okay, to get a loss. And then using this loss, we have to update this weights and biases. Okay, so, and how do we do that? And that's where an optimizer comes in. The optimizer, so the first high level overview would be that an optimizer is just a function where you put in your loss and your learning rate, and you say that I want to minimize this loss. Optimizer is present in the model, right? And optimizer knows the variables. So what it does is it sees the loss and changes the variables so that this loss gets minimized. And how does it changes the variables? It actually calculates the derivatives of this loss with respect to the variables that is present inside the model. It calculates the derivatives and then updates these variables using those derivatives. Are we clear up till this? Anubhav, are we clear that how an optimizer works? Good, good. All right, all right. Okay, so should I move? Gaurav says I'm getting a loss of 950 of 26.10. See, the thing is, Gaurav, it all depends on how it's initialized, and I think it differs because actually in the lens space, no, no, no. It actually differs because of different initialization. Okay, as long as yes, the yes, 6 is right. As long as it decreases, it is okay. You can tweak your hyperparameters and see what works for you. Because there is some difference. There is everything is not the same because there is some random initializations over here. Okay. Okay. Now give me a minute. Okay. Okay, so now we are moving to the QA session, but we have executed the linear regression using sessions. So we are moving actually to the last QA session. But before moving to the last QA session, what I'll do is I'll show you your predicted model. Okay, so let's actually visualize the predicted model. So the first 10 data points of test X and test Y, and let's show it in green, and let's label this line as the true function. By true function, because we are trying to match this, right? And now let's plot the predicted function. Okay, let's show this in red, and this, the points of this will be from spreads, the final spreads. Now let's open up the legend so that you can actually see without any issues, and let's then plot. See, the green one is the true function, okay, and the red one is actually your predicted model, the linear regression model that you created, that you build using your code. Is it cool, everybody? Everybody. Speaking for 2 hours. Yes, it's actually right. Yeah, kind of true. Okay, so this is the last cell that I executed, and people who are getting lots of errors, I mean, not errors, but high loss, those, yes, 6 says that have your queues typed out. Yes, so the questions you have, you can ready those questions. Okay, keep your questions ready. We'll be having a Q&A session right now, and yes, what was I saying? Um, what was I saying? Yes, people who have a high loss, you can actually tweak your hyperparameters. But one thing that comes down to is if you start tweaking your hyperparameters over here, you actually have to rerun a lot of these cells, right? So what you need to do is you need to define one function. Okay, you need to define one function, and uh, in that one function, what you need to do is you need to pass in your learning rate, your epochs, that is all the hyperparameters, your interval, and then put all these code blocks together into that one function. Okay, and then run that function again and again and see how the loss is coming. Do you want me to do it right now? Everyone, do you want me to put all these code blocks into one function and show you that how you can actually execute and tweak hyperparameters easily? Okay, so 6 says that we should leave it as an exercise. I think we should. Yeah, actually, it is quite easy. It's just putting those things together. Okay, so I'm leaving it as an exercise, right? Can you please spam the chat box with yes or no, please? Okay, so I'll be leaving this as an exercise. So that means actually I have completed the execute the linear regression using sessions, and we're actually moving on to the last QA session. So if you people have any questions, then throw them. Me and the moderators will answer them one by one. Okay. So we're moving on to the last QA session, and I'll be showing this uh, function that we built, the linear regression function. Okay. Now let's move on to the questions. Yes, Anu Gupta asked that for long computational graphs, will we do manually? Actually, no. For the computational graphs comes in when you are building models, right? So the thing is that TensorFlow has got APIs which actually builds those computational little parts of the models. So actually you don't need to go through a lot of building, manual building, just a little bit. Anubhav says, what is the need of going over the same data set so many times? I mean, why do we need such a value? Oh, why is a single iteration not enough? Okay. Why is a single iteration not enough? Good question. Very good question. Give me a minute, Anubhav. Right, I see that. Fine. Uh, okay. So the thing is that the it's because of the way the optimizer works. The optimizer is actually seeing. So let's see in detail what's happening over here in case of the optimizer. So you're actually you're actually using this loss, and you're using this optimizer for getting the derivatives, and then you're updating the variables of W and B. Okay, so let's look at in detail what's the update rule. So if this is the weight, then the update rule looks like this: W equals W W dash, which is the previous weight, and then you need to uh, add it using the learning rate. Alpha is the learning rate of the derivatives, which I'm going to write as this. Okay. So the thing is that we are multiplying the learning rates with the gradient values we are getting, because because the thing is that our function looks like this. Okay, see, this is the function. Say you have initialized the parameters over here. You need to reach at this point, right? Now the thing is that you have calculated the loss function, but if you use a learning rate of too much, a high learning rate, then you will actually overshoot this thing. And if you once overshoot, then actually you will come over here, then say there you move back, then you move over here, then you actually move out. Okay, so the thing is that you have to use a small learning rate. Okay, and since you're using a small learning rate, we're actually taking very small steps. Okay, and that is why we actually need to move over the entire data set once and take small step towards the true loss function, true value, true what do I say that our true point in the loss function, and then move over it again. Okay, am I clear? I got too much am I clear? Like, you and do people get me? Like, why do we actually need to use epochs? Arvind says, "Does the okay?" So I guess that question was clear. So after no, so after each iteration, the optimizer actually checks whether we are nearing the required value. Yes. So after each iteration, we check that how what's the loss function, and we update the values according to it. Okay, Anubhav. Okay. So Arvind says, "Does the learning rate remains the same or decrease as we go towards the local minimum?" The thing is that we actually keep our learning rate as constant, but we also have a concept of learning rate decay where we actually decrease our learning rate as we move towards more close and closer to the true function. Because why do we decrease it as we move closer and closer towards the true function? Because there is a very higher chance that we overshoot the global minimum. Okay, so we are moving towards the global minimum, and there is a very high chance that we will overshoot the global minimum. So we keep decreasing it, and this concept is called learning rate decay. But for now, we can keep it as constant. Okay. So Arvind, are we okay? She says that what are the learning hyperparameters that can be tweaked other than the learning rate? For now, actually, you have these three over here: learning rate, epochs, and an interval. An interval is really not a hyperparameter; it's just the number of iterations when you're going to print. So, other than this, you have batch size, uh, and other hyperparameters for in case you're using different optimizers and variables. You will get to know those actually when you learn those. Okay, sure, she. So for now, you can just, I think the common ones are the learning rate, the epochs, the number of epochs you're going to use, the batch size you have. But I think that's all. So are we clear? Everybody, can I get a yes or no? Are we clear? Prakash says, what is vanishing gradient? Okay. Should I take this question up right now? Okay. So I'll go over this. What is vanishing gradient? Very in a very high level. The thing is, when you're calculating gradients, okay, you're actually getting quite low values. Okay, so when you're calculating gradients, you're actually getting quite low values, and when you multiply those very low, very not low, low is not the right word, small, right? So very small values, and when you're actually multiplying those numbers, you are actually getting more smaller values. So ultimately, what happens when you multiply these smaller numbers again and again and again, the final result becomes so small that the gradient vanishes, and at the end of the day, then you are not your gradient is so small that you are not updating your variables. Okay, so that is the problem of vanishing gradients. And the problem of exploding gradients is the completely reverse of this one. The gradients become so high and you multiply those, okay, and so it becomes bigger and bigger and bigger. So when you're using those bigger values, those large values to update your question, to update your weights and variables, your model is actually getting a quite uh, it's getting a very oh, six says if anyone has any questions about today's live stream, may ask. Okay, so yes, so in case of exploding gradients, the thing is that you get very large values, and when you use those large values to update your variables, you actually end up getting a model which is not very accurate. Okay, okay, so I think that's all for now. Uh, what is dropout and how do we use it in TensorFlow? Prakash, I think I'm not allowed to take more questions as I'm getting the moderators are asking me to actually end this session. So Prakash, are you in the MLCC Slack channel? You can tag me and ask those questions over there. Dropout is very similar, very a simple concept. Okay, so I think we are good, and people just let me know if you are. How was the session, and can we use reduce sum in place of reduce mean? The thing about reduce sum is that you're actually summing everything up, and the thing about reduce mean is that you are actually using a mean. Play around with it. You play around with it and see how what results do you get. You get an intuition of what you can use and what you can. Okay. What's next? Okay, so people, just give me a yes or no about how was the session and what's the thing, and then we'll wrap up. Okay, like spam the chat box. Devjit says that the estimator matter. Devjit, do you want like okay, but Devjit, okay, Adrishan 6, can you actually share the link with Devjit? I think he's having issues. Adrish and Six, we can host another session like for describing the estimators. Devjit, I'm really sorry we cannot cover it today because it's already 10:30, and yes. So I think we can host another session. So we can host another session for to explain the estimators. It will be a very short one. I'll go over the same notebook which is hosted in Google Machine Learning Pro crash course. Okay. I'll share the Slack link with you guys for those who wants to join. I just remember I don't have the Slack link. Wait. Okay. Let's see. Okay, so anybody who wants to join the MLCC Kolkata Slack channel, you can join this. You can click on this link, and then you can actually invite yourselves. And if you have any questions, and you'll be notified of all the assignments and sessions we'll be having in the future. Okay, so if you're willing, please join. And if you have any questions, please tag me and others as well, so we'll help you out. Rupam Paul says the homework. Um, the homework. So I'll be giving you out the notebook, which is having, which will have missing parts in it, and PNGs to PNGs for computational graph that you need to build. So you can use that as an homework. And the final homework for the linear regression is actually putting those code blocks together and tweaking the value to get a minimum loss. Okay. So I think we can wrap it up, right? Okay, so bye bye everyone. Have a good night. Okay, practice TensorFlow a lot, and the date actually went on for 2.5 hours. बहुत लंबा है. It was too long for too long to be a date with the hottest deep learning library on earth. Anyway, the notebooks and the video links will be shared in the Slack session. Okay. Okay. All right. Thank you, people. So we'll be ending the session. Yes, Ahmed. Yes, this stream you can watch it. Okay, we'll be ending right now. Okay, 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 okay. Good night. And now I'll be ending the session. Okay. Okay, so I'm ending the session. Okay. Adrish and Six, are we good to go? I'm ending it. Okay. Bye bye, everyone. Have a good night and practice TensorFlow a lot. Okay.